Hello dear participants, I welcome you all again here in this certificate course. In the previous two lectures, we tried to understand the meaning of hypothesis and also we tried to understand the procedures or the steps involved in the hypothesis testing. Moreover, we also have seen that the hypothesis test been classified into two different parts. First is parametric test and the second is non-parametric test. If we are having numerical data or quantitative data with us, usually we perform parametric test, and if we are having categorical data or qualitative data with us, then usually we perform non-parametric test. To make it more simple, if we are having the scale variables with us, then we perform parametric test, and if we are having the nominal or ordinal variables with us, we perform non-parametric test. So there are different tests available here in the parametric and non-parametric test, but in our certificate course we'll perform only the few tests which are very important and which are very common in use for our research purpose. So let me start here with the first category of the parametric test, that is comparing means. What actually we do here in the comparing means? Here we compare two different arithmetic means. Suppose if we know the population mean, we compare this with the sample mean, or we compare two different sample means, or we compare the mean of one variable x before particular time and after particular time. So when we compare the different arithmetic mean, then all those tests, they are covered here in the comparing mean hypothesis test. Here are the different hypothesis test. One sample t-test is there, independent sample t-test is there, dependent paired sample t-test is there. So all these tests are having their own meaning. What is the meaning of all these tests? That also we are going to cover here in the today's and few upcoming lectures. Few upcoming lectures are designed in a such a way that in very first instance, first we'll try to understand that what are the prerequisites of those particular hypothesis tests. Suppose I start with the one sample t-test. Then there are some required things for this test. It is not like that if I'm having a data with me and I can blindly perform any test on my data. It doesn't work like that. It never happens like this. If you want to perform particular test, first you need to understand that what are the required things that we should have with us before performing the test, and those prerequisites first will highlight. So what are the prerequisites that are needed in our data for that particular test? Then we'll see one problem, sample data set we'll refer to. Then we'll go to the MS Excel and S.P.S.S where we'll perform all these tests. We'll try to understand the procedure to perform all these tests, and finally when we'll get the values associated with those hypothesis tests, then we'll try to understand that how can we read and interpret those results. So this is the way that we'll design our lecture. So let me start here with the lecture number 25, and the title of lecture 25 is one sample t-test. Objective of this lecture is to make you all familiar with the procedure of hypothesis testing for one sample t-test using MS Excel and S.P.S.S. Once we follow the procedure, all the procedure, we'll get the values with us, we'll get the result with us. Then we'll try to understand that how can we read and interpret those results. So let me start with the prerequisite first. For the one sample t-test, there are two prerequisites. The first prerequisite is you should know the population mean. And if you remember, this is mu, symbol mu, it represents the population mean. Known population mean is the first prerequisite for the one sample t-test, and the second prerequisite is sample mean, that is x-bar. If these two things are there in your data, then and then only we can perform the one sample t-test. One sample t-test is used to compare the mean of single sample with the population mean. So how it works? For that we'll see one sample data set, we'll see one example. So let me take you all to the example. Here is the given condition. Suppose after a placement through campus, the average salary offered by the top 5 universities is 75,000 rupees. And suppose our university, that is S.R.T.M university, claims that the average salary of our postgraduates is at par with the average salary offered by the top 5 universities. Now what I'm going to compare here, I'm going to compare two things. The claim by S.R.T.M university and the average salary offered by the top 5 universities. And as a researcher, for me, my sample is this S.R.T.M university, and for me, my mu for this particular this problem, the mu is this. So this is the way we define mu. This is the way we define mu. Mu has different meanings, fine. So for this problem is concerned, here my mu, my population mean is this. So what I'll say, mu is equal to, say that 750. I'll use only initial 3 digits for simplicity. Now what I'll do, I'll select random samples of 30 students. Now I just want to check whether my this mean, sample mean is equal to this or at par of this value. Fine. So what I'll do, I'll select the random sample of 30 students from our university, and I'll collect the responses. Fine. So let me collect first the responses. Here are the responses. Here is the salary in say that 100, that is it becomes 63,500, 78,000. So this is the way the numbers are. Fine. Now how to state the null hypothesis? We have seen the problem. We have, means the given condition is there, the data is there. Now how to construct the hypothesis? And if you remember, we construct two hypotheses. The first is null hypothesis, it is denoted by H0, and second is alternate hypothesis, which is denoted by H1 or HA. Anyway, any one you can use. Now for null hypothesis, usually we start constructing statement like this: there is no significant difference, or there is no significant association, or there is no significant relation. So this is the way that usually we construct the null hypothesis. And if you remember, in the previous lecture I mentioned that in the null hypothesis the equal to sign is always used, whereas in the alternative hypothesis not equal to sign is always used, at least for the two tail test. Fine. Now let me take you all to the construction of null hypothesis, more particularly for our problem, the given problem. Now here, what would be the null hypothesis? Null hypothesis, there is a no significant difference between. Now what I am going to compare here, if you remember, I am going to compare mu with one sample mean, and this is a sample, that is the salary, average salary associated with S.R.T.M campus placement one salary. And here this mu is the top 5 universities salary, average salary of the top 5 universities. So I am going to compare these two things. Now if I want to construct a statement for null hypothesis, then what it would be, there is no significant difference between the average salary offered by S.R.T.M and salary offered by the top 5 universities in India during their placement. So here population mean is 75,000 only, and in a symbolic way, null hypothesis is population mean is equal to x bar. It means there is no significant difference. Fine. So this is the way that we construct the null hypothesis. How to construct alternate hypothesis? Opposite to this, just delete this word no, and remaining sentence write as it is. Then it becomes, there is significant difference between the average salary offered by S.R.T.M and the salary offered by top 5 universities. So there is significant difference, and symbolically we represent it, we show it like this: H1 colon mu is not equal to x bar. And we are going to test these things. How to test? Let's see. Now we are approaching towards the process of hypothesis testing. What process that we should follow to get the results? For that, first we need to type our data in MS Excel, and we need to import our data into S.P.S.S. First we'll deal with the S.P.S.S and then we'll go for the MS Excel. So here is the data that I have typed already. Now I'll go to my S.P.S.S, and in S.P.S.S the first thing I should do is that I should import the data. How should I import the data? Simply I should go to file, then I'll go to open, and in that I'll go to data. I'll click on this, then a new pop-up window comes. In a pop-up window, first thing that I should go to this place and I should select the appropriate file type. So I'll click on this and I'll select this Excel because my data is in the Excel. So here I'll find my file from which I just want to drag my data. So I'll click on this, and then a new pop-up window comes, and again here a message comes, read variable names from the first row of data. And if you remember, it is already been discussed in the previous lectures too, that when we type our data in MS Excel, always write or type the variable names in the first row, so that here the read variable names from the first row of data, so that automatically all the variable names will appear here in the first thing, that variable names. Fine. Now simply I'll click on OK. So my variables are here. Now what would be the first step here? If you remember, always whenever we import the data in S.P.S.S, always go to the variable view. So I'll go to variable view, and here I'll verify, I'll cross check whether everything is fine or not, whether the type is fine or the measures are proper, whether the labels been given or not, and the alignment. Suppose if I just want all my numbers in the mid at the center of the column, so you make the arrangements here. So here I have arranged the things, and then I'll go back to the data view. As I click on the data view, now I'm going to perform the one sample t-test. Now how to perform? For that, simply I'll go to the analyze this thing. I'll click on analyze. I'll go to compare mean, and in that compare means, here is one sample t-test. I'll simply click on this. As I click on this, a new pop-up window comes, and in this pop-up window, on the left side, all the variables are enlisted. All the variables are enlisted, and on the right side, there is one option, that is test variable. Now what actually we are going to test? Which one is the test variable? Because there are different, means many variables. Now here we are having only the two variables, that is why only two variables been enlisted here. When there are plenty of variables, you will have to choose appropriate variable for which variable you wish to perform the test, that one sample t test. And if you remember, as we mentioned in the null hypothesis, that we just want to compare two things, that is the salary, population salary, average salary, and the mean salary of the sample. That is, the salary is the test variable. That is why here first I'll select this, I'll put this thing here. Now to do that, let me go here, I'll click on this and I'll click on this, so that my test variable now here in this box. Now what about the test value? Test value is nothing but the mu. It is nothing but the mu value, population mean value. So that value I'll type here. Now here I'll type 750, and the reason is that if you remember, all my data here I've used only initial 3 digits. Fine, this is actually 33,500, 78,000 rupees. Fine, but we have mentioned, we have considered only 3 digits to reduce the complexity in the calculation. Fine. Now here I'll simply click on the open options. I have mentioned the test value here 7750, that is 75,000 rupees for population mean. I'll click on options. Here the confidence interval percentage is 95%. It means my level of significance is 5%. So by default it appears, it comes, but still you should have to go to options and just check whether the proper confidence interval is mentioned or not. Then I'll click on continue, and if I press OK, I'll get the results for one sample t-test. So here are the results. Now if I go further, if you remember, there are two approaches which we use to conclude, which we use to reject or accept the null or alternate hypothesis. And those two approaches are namely p-value approach and critical value approach. Now where to find p-value approach here? Where to find p-values here? If you remember, here are the thumb rules. to reject the null and accept the things, and this already we have discussed in the previous lecture. If our p value is less than 0.05, we reject null and accept alternate hypothesis. If p value is greater than this, then we do not reject the null hypothesis. Now where to find p value here in this result? In this result, simply go to this significant in bracket 2 tail. The value associated with this is a p value. So here the p value is 0.034. 0.034, it is less than 0.05. So which condition is fulfilled here? The first condition been fulfilled, and that is why we simply say we reject the null hypothesis. And if you remember, what is our null hypothesis? That is mu is equal to, say that, sample mean. So this is rejected. This null hypothesis is rejected and alternate hypothesis is accepted. What is your alternative hypothesis? Alternate hypothesis is there is significant difference between these two means, population mean and sample mean. So how can we make the statement? That also we'll see little later. But before that, here using this single value, we came to the conclusion. Now let me explain the other things. In this first table, we are getting the mean salary from my sample. This is a sample mean. Here is a standard deviation. This is a standard error mean. Now, if I come to the critical value approach, these two values now we'll consider, and on the basis of these two values also, we can take the decision, rejecting and accepting thing. How it works? Let's see. For that, let me take you to the further slide. Now if I consider these two values, minus 2.231, and if you remember in the previous lecture also, this thing we already have seen in a two-tailed test, there is some critical value and there is some t-stat value. T-stat value that we compute. How we compute it manually, that also we have seen in the previous lecture. Here t-stat is been calculated by the software, and it is that value is given here. So I'll just mention this t stat value here, minus 2.23. So it is somewhere here, say that, suppose. Now on the basis of degrees of freedom, if we are performing the t test, then, and if we are computing it manually, then we need to go to the table, t table, which is available in every statistics books, where we first have to find 29 degrees of freedom. So 29 degrees of freedom are here, and if you remember, we always try to find t 0.025. It is nothing but, if you remember, at 5% level of significance, this area is 0.025 and this area is 0.025, and altogether it becomes 0.05. Fine. And what we try to find? The critical value here, this critical value. On the basis of this critical value, we compare this value with this value, and then we take the decision. So here t 0.025, the value associated here is 2.045. So where it will lie? It will lie somewhere here. Suppose this is minus 2.045. Though this number is plus, but this is t 0.025, it means it appears on both the sides. So here it will be 2.045 plus, and here it would be 2.045, and this minus or plus 2.045 is nothing but a critical value. This is a critical value. Now this is a critical value, and this critical value tells me that here is the region, and this region is the rejection region, and my t statistic, it lies here in the rejection region. That is why we reject null hypothesis and accept alternate hypothesis. So this is the way that we make the statement, and as of now you must have realized that this is the better, or this is the simplest way to come to the conclusion than this, because if you are going to consider this, you will have to go to the table. In this S.P.S.S, it doesn't give you this critical value. Fine. In MS Excel we get the critical value. How it gets, we'll see little later. Now if I come to this mean difference, what is the meaning of this mean difference? Mean difference is the difference between mu and x bar, and this value, it lies between these two confidence intervals of the difference. So this is kind of intermediate part, will not go into that. If you are comfortable with this p value or this critical value approach, then that's enough, because you go anyway, you are reaching to the same conclusion. Now let me take you all to this graph. The same things, the p value and the t value. Now suppose if this t statistic comparing with the critical value, if I want to show it using the graph, then how it would appear? It would appear like this. Here the t stat is minus 2.231. This is a critical value on the basis of degrees of freedom from the t table we have computed. And if you look at this value is less than this. Fine. And this simple mathematical thing, as we move towards right, so these numbers are greater than these numbers, left side numbers. And what is the thumb rule? So far the critical values are concerned, if your this t stat is less than minus critical value, here the minus critical value is this, and here is your t stat which is less than this number, then we can reject the null. And what is the other condition here on the right side? When it is plus, this is mistake here, it is plus, this is not minus, this is plus 2.23, it is greater than this plus 2.045, that is critical value. Critical value divides the whole distribution into two parts, that is rejection region and non-rejection region. Non-rejection region covers 95% of the area, and this portion covers the 0.05, 0.025, and altogether it becomes 0.05. So all this part we have discussed in the previous lecture too. Here only my concern is to make you familiar with that. How can we accept or reject the null hypothesis? Fine, I hope you understood this. So the simplest way is just go to the significance level, where there are thumb rules 0.05. Now let me come to the conclusion. What is my null hypothesis? Null hypothesis is there is no significant difference between the average salary offered by S.R.T.M and the salary offered by top 5 universities in India. And here is my null hypothesis. Now here are the test results at 5% level of significance, and I came to the test that using p value approach 0.034 is less than 0.05. So simply we can on the basis of this is the proof. Using this proof I can reject null hypothesis and accept alternate. So what would be our alternate hypothesis? There is significant difference between the average salary offered by S.R.T.M and the salary offered by the top 5 universities in India during their placements. That is why this alternate hypothesis that we accept, and on the basis of this we go for the further for the analysis. So this is the way that we follow the procedures. This is the way that we perform one sample t test on our data, and we come to the conclusion. Now what is the process in MS Excel? In MS Excel, simply I will go to the data. Here is my data. Then I will go to data menu. In data menu I will go to data analysis, and as I click on the data analysis, and if I will search the list, I will not find one sample t-test here. So one sample t-test is not here, but still we can perform one sample t-test using one additional variable, and that is a dummy variable. And how it works, let's see. For that I'll go back to my data, and in data I'll just use one variable dummy, and I'll place two numbers 0 0 0 0. Now I'll go to data again, and in data I'll go to data analysis, and then here t-test to sample assuming unequal variance, that particular option is available. Now I'll select this. Actually this is for the independent sample t-test, but we can use this here because we are using dummy variable. Now I'll have to select the variable range. So I'll click on this and I'll just select all my data. As I select my data, again I'll click on this, and now I'll have to select the variable to range. And here the second variable that we are going to consider is dummy, and purposely we have put the zeros here because zero has no meaning actually. But here as I click on this and I'll select this range, then I'll go to the hypothesized mean difference. Here the mean difference is, that is nothing but the mu. Mu you will have to mention here. Mu you will have to mention here, and I'll have to click this label because when I was selecting this range, I have selected this first cell also, first row also. If you are selecting these variables, then you will have to click on this. If you are selecting only the numbers, then there is no need to click on this. Fine. Here if you remember, we have, when we were selecting the variables, we have considered the variable names too. So I'll click on variable labels, then I'll click on this output range. I'll click on this and I'll just click on any empty cell, or I'll select the range, particular range where my results will appear. Then simply I'll click on OK and I'll get my results. Now here are the results in MS Excel. If I now just want to make some statement, on what basis I can make statement? There are two approaches again: p-value approach, critical value approach. So where to find p-value? Here in this table. Here in this table, your p-value is here, p two tail. So always concentrate on the two tail because we are just working on the two tail test. We are not talking about the one tail. No, we are talking about two tail. So here 0.03 is less than 0.05, and if it is the case, then this is a p-value, it is less than the level of significance, then this first condition get fulfilled, so that we reject the null and we accept the alternate. So this is the one way. The second way is critical value approach. What is critical value approach? Here again, what is my t stat? That is minus 2.23, that is t stat. Fine. And what is the critical value? T critical to tail is 2.04. Here it is. And if I draw this thing, then my critical value 2.045, and here it is minus 2.045. Now minus 2.23, where it will lie? On the left side of this or on the right side of this? If I look carefully, minus 2.045. Fine. So this minus 2.23, it will be here, and this is in the rejection region. That is why we reject the thing. This is the one thing. Other way, so your t stat, it is greater. Not t stat, it is actually less. 2.23 minus 2.23, it is less than the critical value, and the critical value is minus 2.045. And here is the condition that if my critical value, if my critical value is greater than the t stat, then we reject the null, accept the alternate. So both the way we can go, no problem. Here in the MS Excel, it gives us the t critical to tail. Fine. But in S.P.S.S, we don't get this value. In S.P.S.S, we get the t stat only. So using these two approaches, we can conclude, we can means at least reject the null and accept the alternate hypothesis. Now let me take you to the S.P.S.S output and MS Excel output together. If I compare both the outputs are same. See, here the mean is 717.67. Here it is almost same. Fine. Here t is minus 2.231. Here the t is minus 2.23. 0.98, it is almost 1. Fine. Degrees of freedom 29. Degrees of freedom are 29. Degrees of freedom is nothing but n minus 1. So there were 30 observations minus 1. It becomes 29. And where we use this, what is the importance of this degrees of freedom? If we are going to refer the table, t table, there we take the help of this degrees of freedom. Now here is the your p value SIG in bracket 210.034. Here is the P for 210 0.0335, that is almost 0.034. Fine. So this is the way that we go with the one sample t test. Either you perform this hypothesis test in S.P.S.S or in MS Excel, you are going to get the same result. Only the way they appear, the way the design or the way they appear, there is minor difference, but the results are same and the conclusion also that we draw is also same. I hope you understood that how we follow the procedure and how we come to the conclusion. Again, the final conclusion is that here is the null hypothesis and here the p value is less than 0.05. So we reject null and we accept the alternate hypothesis. And alternate hypothesis is that there is a significant difference between the salary, average salary offered by S.R.T.M union campus placement cell and the top 5 universities in India, that is rupees 75,000 rupees. It was the mu. Fine. So this is the way that we reject null and we accept the alternate hypothesis. I hope you understood this. Now here are the few examples where we can perform the one sample t test. For example, suppose a bulb company claims something about the bulb life. Then we choose some samples and we collect the information on this, and then we try to find out is there any difference between two. Now the claim about literacy rate, there is a claim about literacy rate, say that you know the mu, and suppose if you collect the information on the literacy rate of a particular category from particular region, and if you compute this, then you can find out whether that mean is significantly different from the population mean. Fine. Any claim for any parameter and sample mean of that parameter, if you choose, you can perform one sample t test. So it was all about the one sample t test. Here we'll stop. In the next lecture we'll perform independent sample t test. I hope you all enjoyed this lecture. Please do practice at your own computers using different data sets. Then and then only you will understand that what actually the how to give meaning to the values. Thank you for your kind listening.